All right, let's get right into it. Today, we're tackling one of the most common and, frankly, most important vulnerabilities on the entire web, cross-site scripting, or XSS for short. If you spend any time online, this is something you absolutely need to understand, and we're going to break it all down.
So let's start with a little thought experiment. Picture this. You're scrolling through a blog or a forum you visit all the time. You see a comment left by some random user. It looks totally normal. But what if, hidden inside that comment, was a tiny piece of code? Code that just by you looking at the page could instantly steal your login info, or worse, start transferring money out of your account. Sounds like something out of a movie, right? Well, it's not. That's the very real danger of cross-site scripting. So, what is XSS at its core? Honestly, it's all about misplaced trust. See, an attacker finds a way to sneak malicious code, usually some JavaScript, into a website you know and trust. The website, not realizing it's been duped, then saves that code and serves it up to other visitors, like you. And here's the kicker. Your web browser sees this code coming from a trusted site, so it just runs it, no questions asked. Your browser thinks it's a legitimate part of the website, but it's actually a Trojan horse, a trap laid by an attacker.
Okay, so a website can be tricked into running some bad code. You might be thinking, so what? What's the big deal? Well, the consequences are a lot more serious than just a pop-up ad. Let's really dig into the kind of damage an XSS attack can do. Because that malicious script runs with all the permissions of the website itself inside your browser. The attacker can basically become you. They can steal your session cookies. Those are the little digital keys that keep you logged in. And boom, they've hijacked your account. They can then do anything you can do, change your password, send messages, maybe even drain your bank account. They can also install a keylogger to capture everything you type or secretly redirect you to a perfect fake of your bank's login page. It's incredibly dangerous. Now, to really get a handle on how to stop these attacks, you first have to understand how they work. It's not a one-size-fits-all kind of thing. It turns out XSS comes in three main flavors. The two you'll hear about most are stored and reflected XSS. The real difference is where that nasty script is hiding. With stored XSS, the attacker's code is permanently saved on the website's server. It's persistent. Think of that malicious blog comment we talked about. It just sits there, waiting, and every single person who visits that page gets hit. That's what makes it so widespread and scary. Reflected XSS, on the other hand, is more of a one-off trick. The script is hidden inside a custom URL that an attacker has to trick you into clicking, maybe through an email. It gets reflected off the server and runs in your browser just that one time. And then you have the really sneaky one, DOM-based XSS. This is a different beast altogether, because the attack happens entirely inside your browser. The server never even sees the malicious code. It works when a website's own legitimate scripts take something from the URL, like your name, to display a "Welcome, Bob" message, and carelessly writes it onto the page. If an attacker can get their code into that part of the URL, the website's own script will accidentally execute it. It's super subtle, but just as powerful. All right, so we know the what and the why, but how does an attacker actually pull this off? What does the process look like from their point of view? Let's walk through the attacker's playbook step by step. Okay, here's how it goes down. First, the attacker finds a weak spot. Anywhere a user can type something in, like a search bar or comment box. Step 2, they inject their malicious script into that field. Then, the website, not knowing any better, either saves that script to its database or immediately reflects it back. Fourth, you, the victim, come along and load that page. The fifth step is the moment of impact. Your browser sees the script and, trusting the site, runs it. And finally, the exploit. The script does its dirty work, sending your private data, your session cookies, right back to the attacker. Now, this might look like a bunch of gibberish, but the concept is actually pretty simple. This little line of code just tells your browser, hey, grab the user's current session cookie, the one that keeps them logged in, then send it over to my server. And just like that, with that one little piece of data, the attacker can log in as you. It is literally the digital version of someone snatching the keys to your house right out of your pocket. Okay, that's enough doom and gloom. We've talked a lot about how these attacks work. Now let's get to the most important part. How do we stop them? How do we build the shields that protect us from all this? This right here is the golden rule. It all comes down to this one simple idea. A browser will try to execute anything that looks like code. The fix, then, is to make sure nothing a user types in ever looks like code to the browser. This is done through something called output encoding. Before any user-provided text is displayed, special characters like those angle brackets, the less than and greater than signs, are transformed into harmless text. So instead of executing a script, the browser just displays it as plain old text. The threat is neutralized. For all the developers out there, this means being really smart about the tools you use. Some functions in JavaScript are just inherently risky. Take inner HTML, for example. Its whole job is to take text and interpret it as real HTML, which of course can include script tags. The safer choice is something like text content, which is designed from the ground up to treat everything you give it as simple, harmless text. It diffuses the bomb before it can even go off. But really good security is all about having layers, right? A defense in-depth approach. So besides encoding, there's input validation. That's kind of like a bouncer at a club, checking IDs and only letting in what's expected. Then there's something called a content security policy, which is a powerful set of rules you give the browser, telling it exactly which scripts are okay to run and which to block. You can also make your cookies HTTP only, which is a special flag that makes them invisible to JavaScript. And thankfully, most modern web frameworks like React and Angular have a lot of this protection already built right in. Look, this isn't just some theoretical exercise for security nerds. XSS flaws have been the cause of some of the biggest and most damaging data breaches we've ever seen. Let's look at a few times this got very, very real. 380,000. Just let that number sink in for a second. What do you think that is? The number of vulnerable websites out there? The amount of money stolen in an average attack? Nope. The real story is much more specific, and it happened to a company I guarantee you've heard of. That's the number of British Airways customers who had their credit card details scraped back in 2018. Attackers managed to inject one malicious script onto the payment page, just one. And that script sat there, silently capturing every credit card number and CVC code in real time as customers typed them in. It's a brutal reminder of the direct financial damage these attacks can cause. And the list goes on. The legendary Sammy Worm on MySpace used a stored XSS bug to spread it like wildfire, infecting over 1 million profiles in less than a single day. eBay has battled attackers who hide scripts in product listings to redirect shoppers to fake sites, and a critical flaw found in Shopify could have let an attacker take complete control over someone's online store. The point is, even the biggest names on the web can get hit. No one is immune. So here's the bottom line. Cross-site scripting isn't some far-off abstract threat. It is a constant battle being fought on the very websites we trust and use every single day. Defending against it requires nonstop vigilance from developers and, for the rest of us, an awareness of what's really at stake. Which leaves us with one final, kind of uncomfortable question to think about. Now that you know the danger, how many vulnerable websites did you use today?